So dear participants, let's start with the next topic in Unit 2 of Programmable Logic Controllers coursework. As we have seen that this particular unit, they are containing three different and independent sections. One is the registers, the other is the PLC timers, and finally there is PLC counters. So in this lecture onwards, we will have a considerable time with discussions on timers that are there in PLCs. Now you see, we will have an introduction to the PLC timers, we will see the PLC timer functions, and we will work with several examples of timer functions that are there in industrial applications. You see, before we get into the timers that are available with PLC, I would like to have a stroll on the generic concepts of timers. You see, since we are all from electronics fraternity, whether we have got some earlier idea about PLC or not, that is an independent issue. But all of us know that timer is a very common concept in electronics. Basically, it is a circuit arrangement or a device or an IC that gives you a signal after a programmed time duration is over. The very basic 555 timer we have known from early days of our electronics lectures. So with that concept, if we want to define a timer, then we can say that timer is a control device that outputs a signal at a preset time after an input signal is received. Input signal means that we are talking of a triggering. When the timer is externally triggered, it starts counting the time. So how much time it should count? It should count a preset time. So that preset time you have fed to the counter, or say timer, sorry. So once that preset time is over, then there is an output signal. Now this signal can be applied in many perspectives, rather in different perspectives, but ultimately what you are getting at the output is a signal. Now the basic structure that you can see in front of you is that of a generic electromechanical timer. Now you see that the first assignment that I would like to give you on timers is you please download different type of timers that are available, rather download the literature of different type of timers that are available with different manufacturers. You may try with Omron, you may try with Select, you may try with Autonix, like that. So at least 3 manufacturers you go, and once you get into the website of these manufacturers, you will find that there are n number of timers that are available. Electromechanical timers are there, fully digital timers are there, digital as well as mechanical timers are there. So this particular timer structure that you can see in front of you is that of an electromechanical timer. Now you see that a timer consists of 4 different sections. One is the basic power supply section that supplies the applied voltage to the internal components. It is needless to say that power supply is required for any of such devices. Then there is an input section rather. This input section receives the signal from the input and outputs the signals to the timing section. The timing section measures the time and output a signal to the output section after specified time, and through the output section the output signals are going to the output devices. This is very simple. Now you see that that particular timer I am talking about, it has got nothing to do with the PLC. This is generic concept of timer. You should not think that only PLCs can develop some time delays or like that. Therefore, I am giving you the basic concept of timers, because the type of timers that are available already in the industrial realm, that has been ultimately transferred into the language of PLC, so that the requirement of timers can be minimized from any control circuit. So now let us see that what are the different operation modes that are available with timers. So you see there are basically 4 different operational modes that a timer can offer. One is the on delay operation, the second is the off delay operation, the third is the flicker operation, and the fourth is the interval operation. These are the basic 4 modes that the modular industrial timers have to offer to the end user. Now let us see each and every operation. Let us first discuss about on delay operation. You see that in case of an on delay operation, the timer first receives an input and then there is the generation of output signal. Now you see, with on delay operation, the timer receives an input and then an output signal is output by switching the timer contacts after a set time delay. This is the important concept, that you give the input. This input is actually the signal that you are giving to the timer, or the trigger that you are giving to the timer. The timer immediately does not give you the output. It will give you the output after a preset time is over. Now let us try to understand why the name on delay is given. This name is used because there is a delay between when the input signal is received and when the output signal is activated. So here you can see the input signal is received and here actually the output signal is activated. The input signal should be a very small duration signal. You need not to keep it entirely continued in order to get the output signal. Once you give the first trigger of the input signal, the counting gets started, and once the preset time is over, your timer output changes the state. Now you see, in case of most of the automated machines, this on delay operation is used. Next, let us look on at off delay operation. With the off delay operation, the output turns on at the same time as the input, and then the output turns off when the timer contacts switch after the set time has expired. You need to understand this. The first one was the case when, suppose you have connected a device at the output of the timer. You now give a triggering signal to the timer, and after a certain duration your device gets actuated. That means getting on of the device, starting of the device is after a delay. So it is named as on delay. On होने के लिए delay हो रहा है. That's why it is on delay. Now the particular operation that we are talking about is the off delay operation. Off delay means that after the input signal is taken off, that means that when the input is turned off, then your output will be turned off after a certain delay. You can see here, this is the input. You have stopped here the input or turned off the input. Still your output is under actuated condition. After a preset amount of time, the output is turned off. Here what is happening? The turning off of the device बंद होने में डिले हो रहा है. The turning off of the device is happening after a preset amount of time or after a delay. Therefore, this is known as off delay operation. If I talk of a typical application of this off delay operation, then car ceiling light can be a very good example. I hope everybody of you have experienced this particular application at any point of your life. Whenever the car ceiling light is in on condition and if the door is open, then the light is always there. It does not get off. Now when you close the doors, then after a certain period of time, the ceiling light goes off automatically. So this is one of the very prominent example of off delay operation. Next, let us go for flicker or cyclic operation. You can see very easily that once the input trigger is there, then the output automatically gets turned on and off, on and off, on and off for preset duration. Now you can see that this on period and off period, that can be programmed. It is not always that your on interval and off interval, they should be the same. In this particular figure they are the same, no doubt, but with modern timers it is always possible that you can program the on duration as well as the off duration. So this is what is called as flicker or cyclic operation. And finally there is an interval operation. You can see here that you trigger the device, your output will remain on for a given duration of time or a preset time. This is what is called as an interval operation. Whenever you find a coin operated tea vending machine where you put the coin and after that for a certain duration of the time the tea will be vended onto your cup. Now you can see that this is never a closed loop system. If you take a small cup, your cup may be overfilled. If you take a big glass, it is not the factor that your glass will be filled up. It is only for a particular duration of time, and this duration of time has been decided by an internal timer. Such type of operation is known as interval operation. So these are the four different basic timer operation, and the same has been translated in the language of PLC also. Now you see another important aspect that you should know is the timer starting method. You have to remember that there are two different starting methods for the operating modes that we have already discussed in case of a timer. The particular example that has been shown here in this figure is of on delay operation. Now you can see that there is signal on delay operation and there is power on delay operation. Okay. Now in case of signal on delay operation, you can find that the power supply that has to be fed to the timer, because without power supply nothing is going to happen. Then you have got facility for an external trigger or input. When the input section receives the signal, then actually the timer starts counting. In other cases, in a simple type of device, you do not have the facility of getting this external trigger. Here actually what happens that whenever you put on the power supply, the timer starts counting, and after that preset amount of time the output is actuated. So these are the two starting methods you need to remember with generic timers that are available for industrial applications. In one case you can work with a power on delay, and in other case you can work with a signal on delay. Since I am talking of this on delay function, therefore I am talking like that. Otherwise it can be a power starting method, power on starting method, or signal on starting method. Very simple. Now there are the devices which are nowadays available. They are so versatile, so flexible, that if you want direct supply to energize the device or instigate the device, that you can do, or if you want some external signal to start the device, that you can also do. So these are the different starting methods which are available with industrial timers. Now let us start our discussion on timers that are available with PLCs. Now you see, PLCs have timers as built-in devices, that they are inbuilt facility. You need not to connect any external or additional unit to the PLC to have this facility. They are always inbuilt. Even if it is the smallest brick type PLC, that will have timer inbuilt into it. Now you see, timers count seconds or fractions of seconds even in using the internal CPU clock. We all know that the CPU is actually a solid state microprocessor, and because of the solid state technology, the timers that are available with PLCs, they are very precise, they are accurate, they are repeatable and 100% reliable. Now you see that the time interval and duration given whatever we feed in the program, it is actually stored in a register. Here you see that even with timers there is the concept of register. As already I have shown you in the register section that there is a holding register, and the purpose of the holding register is to hold the time that we have fed. हम अगर चाहते हैं कि कोई मशीन है जो 3 मिनट बाद चालू हो या 3 मिनट बाद बंद हो स्विच बंद करने की, तो ये जो 3 मिनट के वैल्यू हम टाइमर में फीड करते हैं, हमारे लिए बहुत आसान होता है. There is a window given where we put that figure and we are happy, but actually that figure is translated in binary format and that is stored in an 8-bit or 16-bit register depending on the capacity of that CPU. So whatever the interval or the duration we want to program, that is stored in that register. Now you see that timers in PLCs can be considered to behave like relays with coils that when energized result in the closure or opening of contacts after a preset time. तो टाइमर को सोचना कैसे? टाइमर को सोचना कैसे? अगर आप लोगों ने कभी भी, दिस इज माई पर्सनल कंसेप्शन, आप लोगों ने अगर कभी भी टाइमर से काम नहीं किए हैं तो पीएलसी टाइमर समझना शुरुआत में थोड़ी दिक्कत वाली बात हो जाती है. ये टाइमर में होता क्या है? एक्चुअली आप अगर कोई भी टाइमर देखेंगे, मैं हो सकता है आप लोगों के साथ कोई स्टैंडर्ड टाइमर का वीडियो शेयर करने की कोशिश करूंगा फ्रॉम सम ऑफ द रेपुटेड मेक्स. देखिए, टाइमर के आउटपुट में एक्चुअली यू हैव अ रिले और यू कैन हैव कपल ऑफ रिलेज एट द आउटपुट ऑफ द टाइमर. इनपुट साइड में आप क्या करते हो? इनपुट साइड में यू एक्चुअली प्रोग्राम द टाइमर, एंड इफ इट इज लेट अस टॉक ऑफ एन ऑन डिले ऑपरेशन, आपने सिग्नल दिया या पावर ऑन किया, देन यू विल फाइंड दैट आफ्टर दैट गिवन अमाउंट ऑफ टाइम और द प्रीसेट टाइम, आपके आउटपुट साइड में जो रिले है दैट रिले गेट्स एक्चुएटेड. नाउ वंस द रिले गेट्स एक्चुएटेड, यू हैव गॉट द रिले इन योर हैंड. इस रिले के साथ आगे आप कुछ भी कीजिए, दैट इज नन ऑफ द बिजनेस ऑफ द टाइमर. डेफिनेटली अगर आप एक लोड को चालू या बंद करना चाहते हैं, दैट लोड शुड बी विद इन द कैपेसिटी ऑफ द रिले. दैट्स ऑल विद द टाइमर. ओके, नाउ यू सी in the same fashion, if we consider timers in PLCs, that can be considered simply to behave like relays that have coils. When the coils are energized, then the relay makes change in its state. Now how the coil is going to be energized? The coil is going to be energized when a signal will pass through the coil after the preset time is over. This is the role of the CPU. It helps in counting the time, and once the time is over, it generates signal so that the coil is activated. When your coil is activated, The coil is definitely that of the relay, so your relay will change its status. Now there are a number of different forms of timers that can be found with the PLC. You can have an on delay timer, you can have an off delay timer, you can make it work like an interval timer, and definitely you have got a pulse timer. So all these things are there. And at the same time, I will repeat again and again that all the manufacturers, they have got different format of timers. Different methods are adapted in the ladder language to program the timers. So unless you go into each and every of them, you cannot understand operation of timers in each and every of the PLC. I will try to give you a basic idea of what are the basic traits of a timer, but it is not possible for me to show the programming of each and every timer here unless the practical sessions are there. Therefore, I request that you go to the YouTube and ask for timer operation in maybe Delta PLC, maybe Schneider PLC, maybe Siemens PLC, which will help you to give the idea about the timer blocks that are used in ladder diagram in case of different PLCs. And that will make your knowledge more versatile, and I should say that your horizon will be increased. And this is my particular advice to all of you, that you kindly do this exercise. So I will stop here and start with the next phase of lecture in my next course. Thank you.